Hi guys, good afternoon. This is Sir JP for another discussion vlog, and for today's discussion vlog is about frequency distribution. So what is about frequency distribution? So frequency distribution said that it is a tabulation or grouping of data into appropriate categories showing the number of observation in each group or category. So in frequency distribution, this is just an extension of an array which is distributed in a table and in categories or in a group. So we have here the example of frequency distribution table wherein there is class interval, the tally, the frequency, the class boundary, and the class mark. So parts of a frequency distribution table, we have the class limits or the groupings or categories defined by the lower and the upper limits. So we have what we call the upper limits and the lower limits. So in our example, we have 16 to 20, wherein the 16 there is the lower limit and the 20 is upper limit. So we also have 21 to 25 class, or the 21 is the lower limit and the 25 is the upper limit. And lastly, 26 to 30, wherein the 26 is the lower limit and the 30 is the upper limit. So when we talk about the lower class limits, these are the smallest number that belong to the different classes, and the upper class limits are the highest numbers that belong to the different classes. So you could see there in the example the class 16 to 20 and the class of 21 to 25 and the class of 26 to 30. So next we have the class size or the width of each class interval. Example, we have the lower limit and the upper limit. For 16 to 20, the class size is 5. So this is the coverage. For example, you have 16, 17, 18, 19, 20. That is the class size, meaning to say there is 5 that is belong to that group. So next, number 3 is the class boundaries. Class boundaries are the numbers used to separate class but without gaps created by the class limits. So the number to be added or subtracted is the difference between the upper limit of one class and lower limit of the next class. So example, we have the class interval and we have the class boundary. So in our lower limit, you have 16 and in the upper limit is 20. So in getting the lower class boundaries, we have to subtract 0.5 to the lower limit, which is 16. So when we subtract 0.5, we have 15.5. And to the upper class boundary, we have to add 0.5. So since our upper limit is 20, so we have to add 0.5. That's why it is 20.5. Okay, number 4, class marks. It is the midpoints of the lower and upper limits. This can be found by adding the lower and upper limits and then divided by 2. So for example, in our classes, we have 16 to 20. We have to add 16 plus 20, which is 36, and then divided by 2, which is 18. And that's it for our class mark. So also for 21 to 25 class, in order to get the class mark, we have to add those two, the upper limit and the lower limit, and then divide it by 2, which is the 23, so on and so forth until you get the 31 to 35, which has a class mark of 33. So here are the steps in constructing a frequency distribution table. So for example, consider the data below, which shows the scores of 60 students in a test, in a statistics test. So we have here the data, as you could see. So first step in distribution or frequency distribution is to find the range of the values. When we talk about the range, this is the equivalent of highest value or highest score minus lowest value or the lowest score. So example, based on the given raw data or the ungrouped data here, as you can see, yung mga data na yan. So we get the highest value or highest score, which is 19, and the lowest score is 2. So in order to get the range, you have to subtract those highest value and the lowest value, which is 19 subtracted by 2 is equals to 17. So we have now the range of 17. Next step is to determine the class width by dividing the range by the desired number of grouping. The class size is the width of each class interval. So in order to get the class interval, so we have here x is equals to range over desired number of classes, or the k, wherein our k, to get the k, we have our formula of 1 plus 3.3 log n, where k refers to the number of classes and n is the total number of observations. So example, so to get our k in our given data, as you could remember, there are 60 students who take a statistics test, which is 60 students, or our n. So we have to substitute the value of that. So it is equivalent to 1 plus 3.3 log 60. So as you could see, it is computed there that it is equals to 1 plus 3.3 multiplied by 1.77815, open and close parentheses. And then we have our case equals to 6.87, or 7, approximately 7 class intervals or classes. Thus, we have, in order to get our class interval, we have C is equals to 17 divided by 7 is equals to 2.42. But we have our rule, which is you have to take note that always round up. Even our, decimal places is just 0.01, as long as it has a decimal place or a decimal point, so round it up. So just like in our case, which is our class interval is 3. So step 3, set up the class limits of each class. The class limit of each class are defined by lower limit and an upper limit. Use lowest score as the lowest lower limit. So ayun, yung pagsiset naman ng limits yung gagawin sa step 3. And then in step 4, we have to set up the class boundaries. Again, pag sinabi natin class boundaries, we have to subtract 0.5 in lower limit to get the lower class boundaries, and we have to add 0.5 in the upper limit to get the upper class boundaries. And next we have step 5, tally the scores in appropriate classes, and then add the tallies for each class in order to obtain the frequency. So your number of tallies should be equal to your number in the frequency. And then step 6, solve the class mark or midpoint of each class. In order to get the class mark or midpoint, just add upper limit and lower limit and then divide it by 2. So okay, we also have here cumulative frequency distribution. The less than cumulative frequency distribution is obtained by adding the frequency successively from the lowest to the highest interval, while more than cumulative frequency distribution is obtained by adding frequency from highest class interval to lowest class interval. So 7 naman is relative frequency distribution. Is the relative frequency of a class is the frequency divided by the total frequency or total number of observations, and is generally expressed as a percentage. So we have here the formula: relative frequency is equals to frequency of each class interval divided by the total number of observations. So let's have an example here. Consider the data below, which shows the scores of 60 students in a statistics test. So in our example, in creating or constructing a frequency distribution table. So in our example, we have 60 students who take the test in statistics. So you can see here the scores. Ayan, yung mga yan. Yan yung 60 students na nag-take ng test, wherein this is their scores. But then we have to construct a frequency distribution table, and I already put there the class interval where we compute kanina yung range and decay or the classes, and the class interval which we get is 3. So that's why we have 2 to 4, 5 to 7, 8 to 10, 11 to 13, 14 to 16, 17 to 19. So all of those has an interval of 3. So I already also tally their scores. So ayan, kung makikita nyo dyan, meron akong tally 3. So Now, let's proceed with the frequency. So, we have here the frequency of 3. We have here 9. We have 14. We have 13. We have 10. And we also have 6. So, in order for us, hanapin natin siya, let's compute the total or the summation of our f rather. So we have here 3 plus 9 plus 14 plus 13 plus 10 plus 6. We have a total of 55. Oh, sorry. This is 18. Sorry. Ayan, 18. So we have 60 data. Again, we have the 3, 9, 14, 18, 10, 6, a total of 60 students who take the test. So again, in order for us to get the class boundaries, we have to subtract 0.5 to the lower limit. So we have the 1.5 to 4.5. Since we have, if we subtract to the lower limit, we have to add 0.5 to the upper limit. So next we have the 4.5 to 7.5. Next we have 7.5 to 10.5. 10.5 to 13.5. And next we have 13.5 to 16.5. And 16.5 to 19.5. Now, let's find the class mark or the midpoint of the class. So, para makuha again yung class mark, we have to add these two number, upper limit plus lower limit divided by 2. So, we have 2 plus 4, 6 divided by 2, the answer is 3. 5 plus 7, 5 plus 7 is 12, divided by 2 is 6. So, we have 8 plus 10, 18 divided by 2 is equals to 9. 11 plus 13 divided by 2, the answer is 24 divided by 2 is 12. So, 14 plus 16 is 30 divided by 2, we have 15. 17 plus 19 divided by 2 or 36 divided by 2 is 18. Now, we have our class mark. So, next that we have to get is the less than cumulative frequency. So, in order for us to get the less than cumulative frequency, we have to add those frequency, etong mga to, from lower limit or yung may pinakamababang class, lowest class, which is 2 to 4, until the highest class. Okay, we have here 3 plus 9, we have 12, plus 14, we have 26, plus 18, we have 34, plus 10, we have, 26 plus 18, we have 44, 44, plus 10, we have 54, and then plus 6 is equals to 60. So, it should be equal to your total number of students or number of tests, number of observations, etc. Kung ano yung gusto nyo. Kung, for example, there are number of employees, number of students who take the test, so on and so forth. So, for us naman to get the greater cumulative frequency, we have to add from the highest class, okay, highest class, which is 17 to 19 class, yung frequency until you reach the lowest class. So, we have 6 plus 10 is 16. 16 plus 18, we have 32. 32 plus 14, 16 plus 18, we have 34. Okay, 34. 34 plus 14, you have 48. 48 plus 9 is 57. And next is 57 plus 3 is 60. Okay? So, our relative frequency is equals to frequency of each class divided by to our total number of class. So for example, we have 3 divided by 60 and you should times it by 100 because it needs to be in a percentage. So we have 3 divide 60 times 100 is equals to relative frequency of 5%. Okay? So we have here 5. And next is we have 9 divide 60 times 100, we have 15%. Okay? Next naman, we have 14. Okay? 14 divide 60 times 100, we have 23.33. Okay. So, 18 divide 60 times 100 is equals to 30. And 10 divide 60 times 100 is equals to 16.67. And lastly, we have 6 divide 60 times 100 is equals to 10. Ayan, 10%. So, if you add all of this, it should be 100%. So, let's try. So, 5 plus 15 plus 23.33 plus 30 plus 16.67 plus 10. The answer is a total of 100%. So, that's how we get, or that's how we create frequency distribution table. So I hope that you learned something from me, and that's all. Thank you and God bless everyone.